problem 6, and again, let's see, I think that's 1.1.27 on my screen. And what we're supposed to do here is just use the slope formula to, some people use the one where it does like y2 minus y1 all over x2 minus x1. That's fine. Some people use rise over run. That's kind of what I do, but I do it in a kind of in a visual inside my head manner. Some use the one that talks about the change in y over the change in x, those triangles. There's lots of different ways that some people have learned slope. But I'm going to do this one where I'm kind of thinking about rise over run. Remember, rise is the y's and run's the x's. So if my y is at 5, that's up 5 above the x-axis, and that moves down to go from 5 to just a 1, that'd be going down. So my rise would be a -4. And then I have to go in the same direction. So starting here and going here. If my x is at 2 and it goes to the right 4, that's a positive direction or movement, and that's a 2. So my slope of this line, it's not undefined. Undefined, remember, that's a vertical slope when there's no change in the run or x. So like if I have a vertical line for my graph, like that right there, the change in x, you don't move left or right at all from one point to another on this line. So the run, the x is 0. And remember, you can't divide by 0. So that's when it's undefined. If it's a horizontal line, remember, that would be my change in y is 0 on top. And then my change in x can be any number you want, because you could, if you move from here to here, it might be 1. If you move from here to here, it might be 10. So any number, but 0 over any number, that's still just equal to 0. All right, so on our problem though, we're with a slope because of this rise. 5 down to 1 was a -4, and run 2 to 4 was a 2. -4 over 2, that would be a slope of -2. And that's all you have on that problem.